Welcome back to example number 3. Remember that in 3a, we were given the equation in vector form and we found the equation of the plane in scalar form or Cartesian form. Now, in example 3b, we are given the equation in scalar form and we have to determine the equation in vector form. So we have to find something in the form x, y, z equals x0, y0, z0 plus multiplier direction vector a and direction vector b. So we need to find the coordinates of a point on this plane, and we need to know the coordinates of the direction vectors. Now remember that we can define a plane by knowing the coordinates of 3 points on the plane. And we are given the scalar equation of it, which means that we can find an infinite number of points just by using the equation. So I'm going to start off by writing the equation x minus 2y plus 5z minus 6 equals 0, and I will pick 3 points from the equation. The first point I'm going to pick is, I'm going to call this point A, and I will give the y value 0 and the z a value of 0, and find the value of x. So we'll have x minus 2 times 0 plus 5 times 0 minus 6 equals 0. So this would be x minus 6 equals 0, or x equals 6. So that means that point A would have the coordinates x equals 6, y 0, and z 0. Next, we're going to look at a second point. So for the second point, I'm going to let the y value be negative 1 and the z value 0. Obviously, I don't want to deal with, I don't want to give the coordinate, the variables very high or complicated values like fraction form. Play with something simple. And with y of negative 1 and z of 0, the x value would be equal to x minus 2 times negative 1 plus 5 times 0 minus 6 equals 0. So we'll get the x value here equal to 2 minus 6 negative 4. So on the other side, we have positive 4. And that tells us that the next point, point B, will have the coordinates x equals 4, y negative 1, and z equals 0. The last point, point C, for this point I'm going to let y be negative 1, but I will take z to positive 1. So in this case, then we'll have x minus 2 times negative 1, we said, and then plus 5 times 1 minus 6 equals 0. So we have x plus 2 plus 5 minus 6 here equals 0, which makes x negative 1. So therefore, point C will have the coordinates x equals negative 1, y negative 1, and z equals positive 1. So I'm going to organize the work here a little bit, put it on the side, because we're going to need a little bit of room afterwards. So I like to actually highlight the findings, so the points A, B, and C. And now this problem becomes similar to example 2, where you had the coordinates of 3 points and you had to determine the equation of a plane. So if we have coordinates of 3 points, 6, 0, 0, and then we have B, 4, negative 1, 0, and C, negative 1, positive 1, then we're going to say that we can define two direction vectors. So we can create the direction vectors by using any pair of vectors. Obviously, we want to use AB and, let's say, for example, BC. So we cannot use AB and then BA, right? Because they won't form a plane. They will be collinear. So we're going to say that if we start with vector AB, so from B, subtract A, so we have 4 minus 6, so that would be negative 2. Then we have negative 1 minus 0, that's negative 1. And then we have 0 minus 0, which is 0. And that can serve us, or would serve us, as one of the direction vectors. So we'll say that this will represent the direction vector A, negative 2, negative 2, negative 1, and 0. Next, we're gonna create a second direction vector, so BC. So again, from C, subtract B, because C is the head. -1 minus 4, that's -5. -1 minus -1, that's a 0. And 1 minus 0 is 1. So therefore, we're going to say that the direction vector B will have coordinates -5, 0, and 1. So far we have the two direction vectors, A and B. And we will need a point. And as one of the points, we can choose either A or B or C. In this case, I'm going to go for point B. And I will substitute it into the equation of the plane. So we'll say that the plane pi will have the vector equation in the form xyz equals for -1, 0, and then plus some scalar t times -2, -1, 0, and then plus some scalar s, and then the second direction vector, which is -5, 0, and 1. And there we go, the vector equation. For parametric equations, we will have to solve for each parameter. So we have x equals 4 minus 2t, and then minus 5s. Let me just fix this. Brackets in the wrong spot. And we have here, sorry, easy fix. So we have x equals 4 minus 2t minus 5s. We have y equals -1 minus t plus 0s. So you don't have to write 0s. Just going to leave it there. And last z, we have 0, which we don't have to write, plus 0t plus 1s. So this would be z equals s. And there go the parametric equations of this vector. Okay, I hope this